am Basant Ahmed from Egypt. I am a researcher in Faculty of Engineering at Chemical Engineering Department. I will show my presentation about gas sensor based on carbon nanotubes and conductive polymer composite by inkjet printing. I use inkjet printing to get a gas sensor. Let's go to the content. Introduction about printed electronics and what the difference between printed and conventional electronics. Second thing, fabrication of gas sensor, ink formulation and inkjet processing. Number 3, response and sensitivity of the gas sensor. According to carbon dioxide gas. And finally, the conclusion about the printed electronics. Printed electronics is based on a new materials and manufacturing process. It is expected that market in printing electronics would rise from 7.8 to 20.7 billion at 2025. It is a simple way of fabrication of simple electronic component. Process of printing electronics consists of 3 steps. Printing, curing, and laminating.
Please request you to unmute and not mute unnecessary and
the app.
Elvis.
Okay.
Yeah, please go ahead.
Okay. Difference between the printed and the conventional electronics. Conventional is a high cost. In this may involve a lot of step of fabrication, rigid, high performance, and high capital investment. But the printed electronics, it is low cost. Involves 3 steps of fabrication. It's a flexible, low performance, and low capital investment. Fabrication of gas sensor, it is consist of the main thing is the ink formulation. It's mainly prepared by conductive polymer composite with multi-carbon nanotube to improve the conductivity. We make acid treatment for multi-carbon nanotube to make it soluble in water using aqua regia 3:1 sulfuric to nitric acid. Electronic ink prepared by adding of conductive polymer, and I use polyethylene disulfide polystyrene sulfonate to dimethyl sulfoxide as a first solvent. We use dimethyl sulfoxide as a solvent to improve conductivity, then added ethanol as a second solvent to prevent coffering effect in the printing process. Inkjet and screen printing. Electronic ink was inkjet printed over a rectangular electrode area of 1 centimeter square using Dymatex Fujifilm piezoelectric printer. The thickness of the inkjet printed film could be controlled by varying the number of printed layers, so that 3 and 5 layers were printed on each substrate and immediately dried. This is the actual picture of the sensor. Integrated electrodes were deposited on a flexible and transparent substrate by using screen printing techniques of silver conductive paste. Okay, let's go to the response and sensitivity of gas sensor. Any gas sensor, we can calculate the sensitivity using this equation. Sensitivity equal delta R, difference in the resistance, or change in the resistance, to R8 is resistance of the gas sensor in the air. Okay, I use a homemade gas chamber made of steel. I make my sorry. I make my run at room temperature. This chart was showing that gas sensor sensitivity to carbon dioxide was increased linearly, as you show. The sensitivity increased linearly from 1 or 2% to 5. When I increase the concentration from 100 ppm to 500 ppm of carbon dioxide. Okay, there is 2 lines. First one is a sensitivity of 5 layers. Second one is a sensitivity of 3 layers. About the mechanism of gas sensing for my gas sensor, for carbon dioxide oxidizing gas, it is an oxidizing gas when the sensitive film of BE.BSS multi-walled carbon nanotube exposure to carbon dioxide at room temperature, the carbon dioxide will act as electron acceptor gas. For the BE.BSS multi-walled carbon nanotube and remove electrons from the aromatic ring of the conductive polymers, that is as it's considered a p-type semiconductors. BE.BSS, it is a p-type semiconductor, which enhance the conductivity and decrease the resistance by the depletion of electrons from the valence band, and this cause increasing in the hole concentrations. Conclusion: with the inkjet printing technology, the flexible BE.BSS multi-walled carbon nanotube sensor has proved to be effective in carbon dioxide sensitivity at room temperature, depending on a good dispersion of carbon nanotube with polymer, so that the gas sensor efficiency can be adjusted and future improved. For future Whirlpool electronics technology application, this will be useful. This is the last thing. Thank you.
Thank you, ma'am, for your wonderful presentation.